Hi there, Algebra 1, 4.7, Arithmetic Sequences. Objective to identify and extend patterns in sequence. To represent arithmetic sequences using function notation. Vocab. A sequence is an ordered list of numbers that often form a pattern. Terms of a sequence. Each number in the list. Arithmetic sequence. The difference between consecutive terms is constant. Common difference, the difference in the arithmetic sequence. Recursive formula is a function rule that represents each term as sequence after the first to the ones before. Explicit formula is a function rule that relates each term number. Alright, describe a pattern in each sequence. What are the next two terms of this pattern? Okay, so we want to figure out what the next two are. Well, what are we doing every time in this one? Well, looks like we added 3. Looks like we added 3. Looks like we added 3. So the next one's probably 17. So add 3 to that, and I should get 20. This one looks like we could have added 2.5. That's not going to work because I get 7.5. Multiply by 2, multiply by 2, multiply by 2. Alright, so the next one would be 40 because 20 times 2 is 40, and 40 times 2 is 80. Those are my next two. This one, looks like we added 6. Added 6 works again. Added 6. So the next one is going to be 29 because 23 plus 6 is 29. And then it should be 35. This one, it looks like we divided by 2. Divided by 2. Divided by 2. And the next one should be 25 because 50 divided by 2 is 25. 25 divided by 2 is 12.5. So we just have to find out what the pattern is doing and then keep doing it on this slide. Okay? Identifying an arithmetic sequence. Okay. Now we're kind of getting back into what we should be understanding. Arithmetic is typically one that is going to keep adding. So we want to tell whether each sequence is arithmetic. If so, what is the common difference? Arithmetic sequence is going to always be added. So this one, we added 7, added 7, added 8. So this one is no. Okay, that is not. We add 2, we add 2, we add 2. This one would be an arithmetic sequence. This one we minus 6, minus 6, minus 6, yes. This one looks like we're multiplying by -1, multiplied by -1, multiplied by -1. Okay, we weren't adding there. But we did do the same thing. So is this an arithmetic sequence? No, it is not. Because it's not just adding and subtracting. So, no. The recursive formula, 7, 11, 15, 19. Let n be the nth term in the sequence. Let a of n the value of the nth term of the sequence. So the value of term 1 is a of 1 equals 7. A of 2 equals a of 1 plus 4. The next term is 3 equals a of 3, which would be a of 2 plus 4, and a of 3 plus 4 again. Okay, write the recursive formula for each one. What is the ninth term? Oh boy. Alright, so your a of 1 is going to equal 3. That is part of your equation that you have to write in a arithmetic sequence. Now, the other thing we need to do is going to be find the difference. Plus 6, plus 6, plus 6. So, at this point, we have a of n equals a of n minus 1 plus 6. That would be my formula for this one. Okay? Now, the one thing I have to figure out from this is what it would be to the ninth term. The thing that stinks about the arithmetic is I have to keep going. So this is the first term, second, third, fourth. To find the fifth, I'm going to have to put 21 plus 6, which is going to give me 27. Find the sixth, I'm going to have to take 27 plus 6, which is 31. A to the seventh is going to be 31 plus 6, which is 37. A to the eighth is going to be 37 plus 6, which is 43. A to the ninth is going to be 43 plus 6, which is 49. So a ninth term in this one would be 49. Okay? Same thing we do right here. We're going to do the same exact thing. We have to find out what we're adding or subtracting. We're adding 0.5, adding 0.5, adding 0.5. Okay, a of 1 is always going to be your first value. You have to tell me that, or I can never use this equation. So that is my a of 1. My formula is a of n equals a subscript n minus 1 plus 0.5. Okay, if I had to find the nth term here, this was the fourth term, so a of 5 is going to be your fourth term, 8.8 plus 0.5, which should get you 9.3. Okay, your a of 6 is going to be 9.3 plus 0.5, which is 9.8. A of 7 is going to be your last one. That's why it's n minus it, because my n in this one is 7. So you have n.8 plus 0.5, which equals 10.3. A of 8, which is going to be your last value, plus 0.5 is going to give me 10.5. 10.8. Alright, a of 9 equals 10.8 plus 0.5, which should get you 11.3. That is your answer for the nth. Okay? This one we're adding 12, adding 12. Once again, the a of 1 is going to be my first value. Okay? My formula is a of n, so So whatever the nth term is, this is 1, this is 2, this is 3, and 4. You're going to take that and you're going to go n minus 1. So you're going to go back the one before it. Then you're going to add, in this case, 12 because that's what it's going up by. So if I do that again, my fourth one was 59. So 59, because that's one more in front of that, plus 12 is going to get me 71. 71 plus 12 is going to give me 83. 83 plus 12 is going to give me 95. 95 plus 12 should give me 105. Or 107, my bad. 107 plus 12 should get me 119. That is my ninth term. Okay, that is how you do arithmetic. Explicit formula. Explicit is a little easier yet. Explicit is you're going to be finding an nth term, then you are going to set that equal. So your nth term will equal this. You're going to do your first term plus your term minus 1 times d. Okay? Now, this might not make as much sense as you want to, but we will plug in numbers and I think it'll make a little bit more sense. A subway has a starting value of $100. After one ride, the value of the pass is $98.25. After two rides, the value is $96.50. After three rides, the value is $94.75. Write an explicit formula to represent the remaining value as a card as an arithmetic sequence. What is the value of the car of the pass after 15 rides? Okay. So you start out with 100. Okay. So this is your initial startup value. Going back to my equation. Initial value, this is my A of 1. And that is going to be minus n minus 1 and then we want to find the common difference. Well, every time it is going down by $1.75, I believe. Okay? So, that's how you set it up. Now, when it says after 15 rides, we put in 15 here. And we get 14. We get 100 minus 1.75. So you take 14 times 1.75, you get 24.50, and you'll take 100 minus that, and you get 75.50. All right? That's how you do that one. I'll finish here in a little bit.